Hello calculus learners, today we're going to talk about how to solve algebraic limits. So we're going to deal with how to solve algebraic limits using some algebraic methods. So the very first method that we're going to use is direct substitution, or another way to call it plug-in. Okay, so when we apply plug-in method, if we end up with a numerical value, that's it, we are done. That's going to be the value of the limit. But if we end up something that is unwanted, in this case, we call it indeterminate form. So we have two common indeterminate forms. The first one is 0 over 0, and the second one is infinity over infinity. Okay, so whenever we end up with these two indeterminate forms, we're going to apply some algebraic methods to get rid of that indeterminate form. Okay, so the reason we end up with indeterminate forms that we are trying to evaluate the limits at a discontinuity, all right? Which means when you try to graph those functions at that specific point, you're gonna see hole on the graph, okay? All right, so for all continuous functions, the process is very simple. We just need to apply the direct substitution. So basically, if I'm being asked this question, limit x approaches 3, and then we have a polynomial function, let's say x cubed plus 2x plus 5. In this case, you know, there's no indeterminate form alert, okay? Because when you substitute 3 into this polynomial function, we're going to end up with a numerical value. It's pretty safe to do that. Okay, but what if we have this function, limit x approaches 3, x squared minus 9 over x minus 3. So basically, when you substitute 3 into this function, into this rational function, we're going to end up with this 0 over 0. So in this case, we need to apply factoring method. So what is factoring method? So in this case, we're going to try to factor the numerator, mostly numerator, to try to generate common factors so we can get rid of them, so we can divide them out, okay? That's the factoring method. For example, in order to deal with this limit, I need to factor this x squared minus 9. So let me show it to you. Limit x approaches 3. This x squared minus 9 is a difference of squares and can be factored into x minus 3 times x plus 3 over, so we have x minus 3 in the numerator. So this x minus 3's are going to be gone because that's the common factor. And then we're going to end up with this expression, limit x approaches 3, x plus 3, which is a polynomial expression, which is very, very safe to apply plug-in. So we get 3 plus 3, and then we get the answer 6. Okay, which means at x equals 3, the graph of this rational function has a hole. Then that is causing the discontinuity. Okay. We have other algebraic methods to deal with the indeterminate forms. So we're gonna try to I'm gonna try to show them. So let's try to do some examples. Okay. And we're going to also talk about this special trigonometric limits. Okay, I'm going to show them how to do that. In this problem, it says find the limits, and problem 1. It says limit theta approaches pi, theta times secant theta. So let's try to apply the plug-in. So we get pi times secant pi. So we know that the secant pi can be written as pi times 1 over cosine pi. And we know that cosine pi is -1. My answer will be pi over -1 or just negative pi. So you see that I just applied the plug-in method, and then we ended up with this numerical value, and then we are done. That's perfect. And let's move on to the second problem. In the second problem, if I try to substitute 1 into the denominator, we're going to end up with this. So we get 1 squared plus 5 times 1. Minus 6 over 1 minus 1. Then we have 6 minus 6 over 1 minus 1. So we get 0 over 0. So indeterminate form alert, okay? So we get this indeterminate form. So in this case, if I want to get rid of this factor x minus 1, I need to factor this expression, okay? Okay, using our Algebra 2 and mostly Algebra 1 skills. So we get limit x approaches 1, that's going to be equal to x. It's going to be x plus 6 times x minus 1 over x minus 1. You see that? Bingo. We're going to cancel these two out, all right? And then we're going to wind up with this limit. Limit x approaches 1, x plus 6, which is a polynomial expression, and we can easily do plug-in. So 1 plus 6, and we get this limit value, which is 7 for the second problem. And for the third problem, it says limit x approaches pi over 6 cosine x. You know, it's pretty simple and safe to apply the plug-in. So we get cosine pi over 6, okay? And the cosine pi over 6 is going to be equal to just square root of 3 over 2, okay? All right, let's move on to the next problems. In question 4, it says if a is different than 0, then limit x approaches a, x minus a over x to the fourth minus a to the fourth. So basically, using my Algebra 1 and Algebra 2 skills, I can factor this denominator using the difference of squares, okay? So let's do that. Limit x approaches a, x minus a over x squared plus a squared times x squared minus a squared. Again, this second factor is still factorable, so let's do that. Limit x approaches a, x minus a over x squared plus a squared times x minus a times x plus a. And if you may have noticed that we have these common factors, x minus a on top, x minus a on the bottom. So we can simplify it really quick. So this x minus a's are going to be gone. Then it's pretty simple to apply the plug-in method, because there's no okay, this a value, when you substitute it, it's not going to cause discontinuity. Okay, it's not going to cause this entire function go undefined. So let's do that. We get 1 over a squared plus a squared times a plus a. Okay, so we get 1 over a squared plus a squared, we get 2a squared times a, we get 2a. So when you multiply, we get 1 over 4 times a cubed. So 1 over 4 times a cubed, that's the limit value. Again, notice that for this problem we used factoring method. Okay. All right, let's move on to question 5. In question 5, we have this piecewise defined function. It says limit x approaches -4 rx, and for all x values that are not equal to -4, we're going to use this piece, and for all x values that are equal to -4, we're going to use this value. So basically, limit x approaches -4, r of -4 is going to be equal to just 1.7. Okay, that's the value. All right, question 6. In question 6, we have this trigonometric function. So whenever we have a limit involving trigonometric functions, we need to know these two trigonometric trigonometric limit formula, let's say. Okay, so the first one is limit x approaches 0 sine x over x is equal to always 1. But we have one restriction. What is that? That restriction is that x has to approach 0. If x is approaching 1, then we cannot apply this formula. Okay. Also, we can generalize this formula into this. Limit x approaches 0 sine of f of x over f of x, which means, and this is also equal to 1. So which means if we, inside the limit, if we end up with the same function inside of this sine x on top and also on the bottom then the limit is going to be equal to 1. So what I mean is, I'm going to give a quick example. So if I have limit x approaches 0 sine 3x over 3x. So notice that we got the same inside function 3x on top, and we got the same function 3x on the bottom. So the answer is going to be equal to 1. And also notice that x approaches 0. Okay. Another quick example here. Limit x approaches 0 sine squared 2x over 2x squared. This is also equal to 1 because we have the same inside function on top and same function on the bottom. Okay. So in the light of this information, we're going to do this question 6. So whenever we have problems, limit problems, and whenever we try to evaluate these limits involving trigonometric functions, we need to reduce this trigonometric expressions into the forms that we know of. Either this one, limit x approaches 0 sine x over x equals 1, or this one. Okay, so in the light of this information, let's try to do question 6. I'm going to erase. Okay, so in question 6 we have this limit x approaches 0 sine 5x over 2x. So first of all, I have to be focused on the inside function right here. So my inside function is 5x. Okay, inside function. Okay, so basically on top I have 5x, and on the bottom I have to have 5x also. Okay, so how do we put 5x in the denominator? I'm going to show you. So limit x approaches 0 sine 5x times 5x over 2x times 5x. You see what I did? So basically I multiplied and divide this entire expression by 5x at the same time. So it's not going to change anything, because if you multiply the original expression by, let's say, 2 over 2, so we know that 2 over 2 is already 1. So basically 5x over 5x is already 1. Okay, let's continue. Limit x approaches 0. We have sine 5x over 5x and times, so basically I'm just breaking things and trying to put the things together, and then we have 5x over 2x, and then these two x's are going to be gone. Okay, and then notice that you can put this 5 over 2 out front, so you get 5 over 2 times limit x approaches 0 sine 5x over 5x. And notice that we ended up with the same inside function, 5x on top and 5x on the bottom. That means this limit is going to be equal to just 1. So basically 5 over 2 times 1, and our answer will be just 5 over 2. Okay, so our ultimate goal is to reduce given trigonometric functions into the ones that we know of. Okay, let's move on to the next slide, and this is our last problem. It says if g of x is equal to 3x cubed minus 5, and we're going to try to evaluate this. So limit x approaches 0. We know the g of x function, which is 3x cubed minus 5, and minus g of 0 will be, when you just substitute 0 right here, you get just negative 5. Okay, and over x cubed. So from there we get limit x approaches 0, 3x cubed minus 5 and plus 5 over x cubed, and then this negative 5 and positive 5 are going to cancel each other out, and then we're going to end up with limit x approaches 0, 3x cubed over x cubed, and then these x cubes are going to be gone. Let me use a different color, and now we get limit x approaches 0, 3. So when you take the limit of a constant number at any point, and the limit is going to be equal to just that constant number, which is equal to 3. All right, guys, let me recap what we have learned today. So we've learned how to evaluate limits using algebraic methods. So the very first method that we need to use is plug-in method. So I'm going to write it down here. So the first one is plug-in. So when you apply plug-in, and if you wind up with a numerical value, you are done. That's perfect. Okay. Then if the plug-in method fails, which means if you end up with indeterminate forms, which are 0 over 0 and infinity over infinity, then you need to apply either factoring method, that is, that is totally dependent on the question, factoring method, or you can apply multiplying by conjugation. We're going to solve some questions about that in the practice video. Okay, please stay tuned. So we call that method rationalization. Okay, and then we also apply if we have complex fractions. Okay, we're going to apply these methods. Okay, so for rationalization and complex fractions, please try to stay tuned for the other videos, practice video. I'm going to show you 15 questions about this evaluating limits algebraically. And also we've learned how to evaluate trigonometric limits involving sin x. Okay, so which is limit x approaches 0, sin x over x is equal to 1, or let me erase this part. If we have the same function on top and on the bottom, if we try to generalize this formula, we get limit x approaches 0, sine of, let me use different colors so you can understand better. Sorry. Sine of f of x over f of x. And notice that we have the same function on top and the bottom, and this is going to be equal to just 1. Alright guys, thanks so much for watching this video. Please stay tuned for the practice video and have a good day.